Hi, I'm Adam Chalmers, and I'm an engineer at KittyCat, a little startup. Our startup has a lot of Rust code. Most of the company is built on Rust. So every week, I run a little session for the other employees of the company who haven't had as much Rust experience to get to learn the language and get to understand how it all works better. We always record these Rust tutorial sessions so that we're slowly building up a backlog of Rust learning material for new employees or just for existing employees to look back on. Anyway, this week I realized, hey, people outside our company might also benefit from some of these videos. So we've decided to start putting them on YouTube for free occasionally. Without any further ado, here's the first one. We're looking at how to build parsers in Rust. So if you've ever wanted to know how that works, this is your chance. We're going to be using the winnow crate. So here you go. Here's the recording straight from our session.
Right. So there is a library called nom. It is very kind of old and loved part of the Rust ecosystem. And unfortunately, it's not the maintainer's full-time job to write nom. So he took like a year or so absence from it and is kind of working on a new version right now. But at RustConf, I met the maintainer of Clap and Tommel. And he's also got his own, he forked nom and is kind of making his own new variation of nom, which he thinks fixes a bunch of problems with it. And so I got curious about it and I wanted to experiment with it. So I was doing that earlier today. I think we're going to use that instead of nom. So this crate is called winnow. So I'm going to add, add winnow to it. Cool. So I think a good example to start with is parsing an HTML tag. So they look like this. Something like let's make this a div, just because that's standard. So there's three kind of general purpose ways you can write a parser. There's one, parser takes in text and outputs a kind of structured representation, some kind of Rust value or whatever language you're using. And there's generally three ways people write these. You can either, one, write it by hand, where you kind of take in some text and you recurse over it usually, or you loop through it and go character by character and start trying to parse things, and if you fail, you backtrack and you try again. These can be very fast, and they can have really good error messages, because you're kind of handwriting all the logic yourself. You can put in all the nice error messages you want to, but they can be kind of difficult to maintain and difficult to build. And they can always lead to bugs, because you're handwriting a lot of this logic yourself. So it's kind of common for them to wind up with infinite loops or stack overflows or going out of bounds, reading the wrong characters. The other method is to use like a parser generator, where you kind of write out the formal structured rules of your language, and then you run through some program that applies them. And they're totally fine, but I think they're kind of hard to customize and change. And third approach is called parser combinators. That's what we're going to use. With parser combinators, you start with a set of really small, easy parsers, like a parser to parse like the word div. And then you use combinators that take in simple parsers and make more complex ones. So for example, it might be a parser called like many, which wraps up another parser and pulls p many times. Or it might be one called separated list, which pulls p many times, assuming there's a comma between everything matched by p. So we're gonna kind of see examples of these things. I know it's weird to to just try and understand the theory at first. But any questions so far? Okay, cool. So the trick with a parser combinator library, like I said, you want to start small. Start small and simple, and then build from those simple parsers, build them up and combine them into more and more complicated parsers. So I think firstly, let's make a parser just parse one attribute, one key, equal sign, quotes, and then the value. In fact, maybe even that's a bit too big to start with. Let's just try parsing just the key part. So we're going to take in an input, which is a mutable string. We're going to return this type here. So p_result stands for parse result. It's a type that comes from Winnow, and it's either an error about why you couldn't parse something, or it's the thing you were trying to parse. And this input type here is kind of weird. But all it's really saying is it's saying we've got a... Let's build it up from small parts. We've got a string slice. So remember, it's pointing to some big own string somewhere, and it's giving you a kind of smaller slice of it. So a slice has a pointer to the original big string somewhere on the heap, and it's got a start and an end. And so generally, we don't change slices once we've used them. But in Winnow, we actually are going to be changing the slice, because we're going to be parsing out one little bit at a time. And every time we parse a character out of the slice, we're going to shrink the slice a little bit. So for example, we might have a string like width equals 40. And at the start, we're going to have a slice that kind of looks like this all the way here. It's going to be covering the entire bit of the string. And then as we pass each character, the slice is going to shrink a little bit. So we're never changing the string, but we are going to change the slice boundaries. So that's why we're putting this mutable part here. We've got a reference to a string, and we are mutating its boundaries. And because there's two ampersands here, there's two references. Yeah, so this is kind of the reference to the underlying string, and this reference is just saying that the slice here, we're changing what slice of the string we have. But yeah, we shouldn't actually need to think too hard about it so far. Any questions so far? Cool. Okay, so for now, let's just say that the key is, any sequence of just alphabetic characters, just A to Z. So Winnow comes with a couple of built-in kind of primitive simple parsers. So we can say alphanumeric. And we're going to parse next. Cool. So let's have a look at this. Alphanumeric 1 parser recognizes one or more ASCII numerals and alphabetic characters. Okay, works for me. And then generally with Winnow parsers, you call the parse next method, and that'll get one. It'll try to get one of these things, whatever you're calling. So it'll get one, or it'll run the alphanumeric parser one time. And if it can't get anything, it'll fail, and we use the question mark. So let's take a look, and let's write a little test for this. Our input will be just width. And then we'll run it. Okay. Pretty straightforward so far. Any questions so far?
So that would handle if you had a 0 at the start of the key, that would allow that, right?
Yes. So let's take a look. But we don't actually want that, do we?
And if it had like it says 1 or more, so if you had nothing, then if it was empty, then it would fail. Is that how it works?
Yeah, let's see what happens if we put in the empty string. Yep, it fails. Because the alpha, so this is a really common pattern. You'll see that they're named alphanumeric 1, and there's also alphanumeric 0. So obviously the 1 recognizes 1 or more ASCII numeric characters. If we change it to 0, then it recognizes 0 or more. So now it should pass. But in this case, we actually do want the key to have a positive length. And we said for now, I think we said that these should just be alphabetical. So let's just change this to alpha 1. Okay, so the important things here are to look at the input type and the output type. Input is going to be the string. The output is, the input is like a mutable string slice that we can change if we parse, and the output is a string. Okay, let's take a look how we're going to parse the value now. So parse value is going to be very similar. But let's make this a little bit more interesting than just copying the exact same thing over again. So let's say we want to make the values should be able to contain other characters besides just letters and numbers. So let's parse key. So an example value, say you're making a hyperlink, you might want to put a website in. So let's make the value. Actually, let's just start with a string for now. But the key is that, the main thing here is that if we look at the example, the value has to be in quotation marks. So we don't actually care about the quotation marks. We don't want to return them in the end. We want to parse them out and discard those quotation marks. So the test case here is going to be something like, so Rust has a special r/ syntax here, and this is a way to escape characters like the quotation mark. Put a quotation mark in here now. It knows that the string is only terminated by if there's a quote with a hash behind it. So this is really useful if you're trying to, say, put JSON in a string, because now you don't have to manually escape every quotation mark in the JSON. Okay, so parse value. What's this complaining about? What did I do wrong? It was working before. Oh, okay. I think it is. Nope. Okay. Don't know what went wrong there. So with our parse value, I'll show you an example of how you have to escape these quotes. So, input and expected are the same thing, but in one of them I'm using the special kind of escaping syntax with these are called like reserved literals or something like that. If you don't want to use that, you can just use the standard kind of / quotation mark stuff. So, parse value. So we don't want to just parse out the entire thing. We're going to use a combinator here called delimited. So you can see it runs 3 parsers in sequence, but it kind of discards the first one, keeps the second one, and discards the third one. So in Winnow, basic characters implement the right kind of parser trait. So we can put in these basic characters here. Oh. So let's say yeah. So the delimited parser is going to parse one character, the open. Nope, I didn't mean that. I meant to put a quote. It's going to parse a double quotes mark, then parse one or more alphabetical characters, and then parse another double quotes mark. And this defined a parser, this whole delimited block here. And then we're going to run the parser on the input, and we get this string slice. And we'll convert it into a proper owned string. So let's see if this works. It did not work. Oh, because we don't actually expect this to have quotes anymore, do we? We expect them to be discarded. Okay, now it works. Any questions about this so far? So the key part is we've got these like primitive simple parsers like alpha1, and we've got more complicated parsers like delimited, which are parser combinators. So you take the combinators call primitive parsers, and you get a new parser. So we can again just keep building these up into more complicated ones like parse an attribute. So this should parse something like that. So we're going to return 2 strings, right? The key and the value. So there's probably some combinator to do that specifically. Separated pair. Yeah. Sequence is 3 parsers, but discards the middle one. Only returns the first and the third. That's exactly what we want. Parse key. The separator is the equal sign, and then we'll parse the val.
How is whitespace handled? Is whitespace ignored? Or...
So whitespace is just like any other character. You've got to be explicit about what you want to handle. And we can make our parser kind of simple at the start, and then we can handle more complicated cases. So let's see what happens when we actually want to do that. Let's make this nope, don't want to type in. We said width equals 40. We're going to parse attribute. And we expect the result to be width and 40. Oh, yep, it expects in strings. What went wrong here? Okay, it failed to parse. Panicked, called unwrap on an error value. The parse error. See, this is the input. Didn't give us any more context.
It's both alpha, right? Your value is now not alpha. It's alphanumeric.
Yeah, okay. That's a great point. Thank you. So this is why I find the key with writing Parser combinators is to really start small and test each one as you go. So really, we should have had another test case for this val, right? Width is not a good test case. If I had written the test case was more realistic, we would have caught this. Right, now it gives me an error. I can change this value to be alpha numeric. Now everything works. Okay, so David, you were asking about whitespace. This, as you pointed out, will not currently handle whitespace. Let's make a new test. Test attributes with spaces. Width equals 40. So we really want this to parse out the same thing, right? Because the HTML structure isn't changing. It's just the specific way we've written it that's changed. Of course, it fails. So let's have a look at how we make this a bit smarter. We want to say this could be, the equal sign could have a white space on either side. So we had that delimited one before. I wonder if we can just change this. So there's a multi-space matcher. You can see here it recognizes 0 or more spaces, tabs, carriage returns, and line feeds. So that might be a little bit more general than what we want. Do you think we should tolerate just a literal space character? Or should we tolerate any number of space characters? Or how about tabs and everything too?
That's okay. I don't think there's any rule against that, is there?
Yeah, I think it should be okay. Let's see what happens now. Yeah, so that's all parsing now. And we can just do a little tweaking here and make sure it still works. Works with one side, works with the other side, works with both sides. Cool. Okay. Any questions so far? Okay, cool. So before we go any further, there's one performance problem here, which is that every time we parse out a key or a value, we're allocating a new string. And there's no actual reason to do that. It would work just fine if we just passed slices to the string. Like, this would be a totally acceptable way to do it. We don't need to have an own string. The caller, if they want a full capital S string own string, they can always call toOwned or toString if they want to. The difficulty is then we need to change the return type to return a string slice. And then we run into this lifetime problem here. So we need to stop providing lifetime parameters. And I actually think the Rust error here is certainly way better than it used to be. It's explaining exactly what we need to change, right? It's saying it doesn't know if the lifetime of this string we're returning, should that be valid for the lifetime of this reference or of this reference, right? Because the string is probably going to live for longer than the slice of the string, right? The string might live the entire duration of the program, and the slice might only live for as long as we're parsing. So we need to choose a lifetime that this string should match. So I want to say that, I think it's, to me, pretty... The way that I'm thinking about this is that, this lifetime should be the lifetime of the overall HTML string input that we're being given. Because really, we're handing back a pointer to somewhere in that original input. So I'm going to call this lifetime I for input. I'm going to declare it here. And then I can say, I have a mutable string slice. I have a mutable slice over the string. And the string itself is a, where did it go? The string itself is somewhere else in the heap, and it's got some, we're pointing to it, and we've got some lifetime. So we've got this slice to the string that lasts for the lifetime named I for input. And then this parser has a little mutable slice to this slice over here. So we're mutating our little window into it. We're never mutating the actual string itself. And we're going to hand back a pointer somewhere back in the string itself. Any questions about this? Okay, well, we can do the same trick down here. Actually, let's return this whole thing. Means now this needs to return 2 pairs of strings, which means this needs a lifetime. Okay, cool. So now we're not actually allocating anything anymore, right? We don't need to put any new values onto the heap. So this should be, if this was in like a tight performance loop in like the middle of the hop path, this would make it a lot faster because we no longer need to find memory on the heap and then set it all up and write it there. And let's just make sure all of our tests still pause. Okay, well the tests don't compile, but it's probably just because we're calling toOwned in a lot of places. One more change. Okay, cool. So far, we've always returned string slices, but frequently we'll want to return something a bit more complicated. Let's make a struct for holding all the attributes in a certain tag. Something like cool. So this is going to be the attribute list of a tag. Right, it's going to be a hash map where the keys are string slices and the values are also string slices. So let's add a parsing method to this. Again, we're going to take in some input string. And we return the parsing result of this thing itself. So there's a repeat combinator within Winnow. It takes in a number of times to repeat something and what to repeat. So we're going to say repeat it 0 or more times. And what are we repeating? We're repeating this parse attribute. So imported. It's not called I, it's called input. Yeah. So
I'm impressed by how like fluent it is. It's pretty like self-documenting, really, isn't it?
yeah. It's actually one of the things that's easier to read than to write, I think, because when you're writing it, you have to know which combinators to choose. But when you're reading it, it's clear. Once they've already been chosen, it's generally pretty self-explanatory what they do.
Yeah, I totally agree. I mean, because I think the Rust step crate uses nom, which is I think predecessor to this one, as you said. And
yeah, this is a fork of nom, so
it's very obvious when things what it's doing and where things are wrong. But actually, if you're going to fix things, you have to like really think about it. It's like solving a puzzle.
Yeah, it is. And I like and I don't like that puzzling aspect of it, but yeah, it is really good when you can make it all work. And I like that it almost becomes self-testing as well, because you're usually testing each step as you go. So we can just do like kvs equal this. What went wrong here? Oh, we just need to wrap it in. Okay. Nice. Cool. So then let's just make a little test for this as well. Actually, we can probably just change these tests. So now I'm going to have width equals 40, height equals 30, and attributes with kvs. Oh yeah. Right, and we need to put some things on, derive some traits, debug. All right, what went wrong here? Okay. So the other thing is, in this list, we want to separate them by a comma. We don't just want to repeat the parser a whole heap of times. We want to make sure that as we're parsing out each attribute, they're separated by a comma. So let's put that in. There's a separated list. The parser is going to be parse attribute, and the parser for the separator will just be a comma. Okay, that works nicely now, but it would be nice if we could also tolerate a space after them. So there's this nice little terminated Yeah, so terminated takes in two parsers, and it runs the first one, and it runs the second one, and it discards the second one. So it's kind of not really necessary here because we don't really care about even keeping the first one, but it's, an easy way to run two parsers. There's also a similar one, which is proceeded, which keeps the one and ignores the first one. And if you want to keep both of them, you can just use a tuple. So tuples are going to automatically implement the right trait that we need. And they just run each member of the tuple in sequence. Okay, so the last thing we need to do is to build a parser for an actual tag. So an HTML tag, we're just going to say has the tag type, and then attributes. So the tag type will be something like, like the keyword div or something like that. So to parse that, let's just copy our little parser implementation here. We're going to so the tag itself will be, let's put a little example up here. No, we already had this example here. So we need to, firstly, we need to discard the little opening and closing tags, and then we're going to parse out the name, and then a space, and then the attributes. So I'm going to put delimited. And what's going to go in here? We're going to parse out, firstly, the name of the tag. So we can just use alpha1, I guess. And then a space. And then the attributes. And once we've got that, what's this error here? It's saying that the middle parser is incorrect because this middle parser is returning a tuple. It's returning three things. Here, let's move this into its own variable. Right, so quite reasonably saying that this is returning, here we go, yeah. It should return a result with a tag, but it's not. Doesn't really tell us that much about what it is returning, but you can see here the part of the type signature. It's saying it's returning a 3-tuple with a string and a character and the attributes. So basically, we don't want this child parser, this inner parser. Let's call this inner parser. This inner parser is returning a 3-tuple, and we want it to return capital S, self, which is tag. So there's this map method that comes in handy here. We can take in the tuple with the tag type, the space character, and the attributes. I did think that would work. Mm. Okay. Just forgot to actually call the parser there. Okay. So yeah, this .map method, this is a really key concept because frequently you'll be building up parsers from tuples or something like that. And then you want to convert them into whatever type, into the nice struct types you have. So let's put this into its own variable so it's clearer. Let's call this parse parts. Parse tag. There we go. Okay, and let's have a little test to make sure that this works. But any questions about this before we write the test? Okay. Well, let's copy our test case from up here. We'll expect tag with tag type is div, and the attributes just copy that actually. Yeah, okay. And then actual equal. Oh, we're gonna call the parse method. Okay.
Are these like
Comma.
these associated functions with the parse? Is there like a trait that encompasses that, or is it just ad hoc every time?
There is a trait which encompasses it. Yeah. If we take a look at this parse method here, we can see there's the this is within the window crate, pub trait parser. So nom actually really exposed you to this trait much more, and I think Window does a better job of hiding it with these kind of helper functions. But the key is the parsers have 3 generic types. They have an input, an output, and an error. So here, for this parser here, the input is text, basically. So it's a string slice. The output is the type tag, and error actually has a default type. I don't see where they're setting the default error type here. Maybe it's in parse error. I don't know where they're setting the error.
That is quite involved, though. I mean, I can't imagine there would be much point in actually implementing that, rather than just writing it yourself.
Yeah, you never really need to implement the trait because they've given you all the combinators, which spit out the right implementations anyway. But if you do want to implement it, it's pretty straightforward actually, because all you need to do is say, okay, my parser, firstly the parser itself can have some mutable state. Fair enough. You take in the input and you return a result. If it's okay, you return the output type. And if there's an error, you return the error. And the error can reference the input to point at exactly where the error happened. So that's why the error has the I and E generics. And they've even got a default implementation of it. So, yeah, that is my introduction to Winnow. Any other questions so far? Okay, cool. Well, there you have it, I guess. So this is actually a very practical library. You can see like David pointed out, all the little methods themselves tend to be quite nice and self-documenting. You can even, make them a little bit neater sometimes. Okay. Yeah, you can just, there's no point using the return out there because you're just unpacking the error and then putting it back into an OK. So yeah, I kind of like that it becomes self-documenting in a way. And generally the way that I'm doing it, I do this kind of TDD approach where everything's very well unit tested. We can even check the coverage. Yeah. Everything except the main is covered. So, yeah, it kind of naturally built up to be covering all the lines. So, the one thing I want to take a look at, if we have a few minutes left, unless anyone has any questions, is how does this alphanumeric 1 actually work? Because frequently you want something a little different to alphanumeric 1. Right, let's say we wanted to change this so that we wanted to parse out like an A tag, for example. So A, then we'll just use href. So this should be. Now, I don't expect this to work because dot character is neither alphabetical nor is it numeric. So we do indeed get a crash here. So really, I'd like to generalize this parse val. So it's not just alphanumeric, it's something else. So I actually was not sure how to do this, but if we take a look at the definition of alphanumeric 1, how are they defining it? So this is appearing into the Winnow source code. We've got this trace combinator, which you can see is kind of wrapping another combinator and adding tracing information for debugging purposes. I'm not too worried about that. Let's just have a look at the implementation. They use take while. They give it a range, which starts at 1 and can be up to any number of characters. And then as character is alphanumeric. Let's take a look at the implementation of that. Is alphanumeric. Okay, it takes in self and returns a bool. So we can actually implement something like this by saying take while, just like they did, a range, just like they did, and then we're going to write, I think I have this correct, closure. So this is doing the same thing now. This really is just exactly how they implemented the alphanumeric parser. But this time we're going to also allow if C is the dot character. Shit. I thought that would work. Oh, it's just the test updated correctly. This is an A, not a div. So yeah, that works nicely now. And if we try to put in the full thing, it'll break again because the colon and the slash not in that set. But we can just add them in. Oh, probably just didn't update the test expectation. Yep. Okay, cool. So the nice thing is, again, this is all just giving us one string slice. So this still isn't allocating anything. You could make a slower version of this a bit more easily by, giving like a list of characters and doing repeat over, or like a sequence or a tuple of characters. But yeah, the nice thing about this is that it doesn't allocate anything. So it can be super, super, super fast. Yeah, how to like extend the built-in ranges did kind of confuse me for a while, but earlier today I just looked at the source code and figured out what they were doing.